Hello, I am Yuksha, and in this video, I am going to share some insights on what is the role of digital logic in voice assistants. Let's start with an introduction. Voice assistants like Siri, Alexa, and Google Assistant have become a part of our daily lives. We speak, and they respond back to us intelligently. The core idea of this presentation is to understand what is the digital logic that forms the building blocks of how voice assistants processes voice commands, make decisions, and interact with users. The objective of this presentation is to explore the role of digital logic in enabling the complex tasks performed by voice assistants, from detecting your voice to providing accurate answers. From sound to pitch, voice is analog, and as we know, computers can only understand the digital language. That's the binary language, that is zeros and ones. For that, we have to convert them from analog to digital. For that, ADC, that is analog to digital conversion, takes place. This is the first step where sound waves are converted into digital signals so machines can process them. Next step is sampling. The ADC captures snapshots of the sound at regular time intervals. This is known as sampling. Third step is quantization. Each sampled value is assigned a numerical value, a binary code representing the closest match from the set of levels. And final step is the digital signal processing (DSP). Once in the digital form, the sound is filtered, enhanced, and analyzed using algorithms to extract useful features, and at last, the output is given back to you. This is the flow of how the voice that is analog converted to digital signal. That is, from first it is converted to the analog to digital conversion takes place, then sampling takes place, then quantization, and then at last DSP is then the building blocks. Now we will understand how logic gates are how the basic logic gates are used in such complex circuits. Digital logic is built from basic components called logic gates, such as AND, OR, and NOT gates, which are the basic logic gates. Each gate processes binary inputs that is zeros and ones to produce a specific output. By combining gates, we create complex circuits that perform advanced operations, powering everything from simple decisions to intelligent systems like voice assistants. Combining complex circuits. Logic gates work together to build more complex digital circuits that form the core of computing systems, the adders and subtractors. They perform the basic arithmetic operations essential for calculations and processing. Multiplexers and demultiplexers, they act as data routers that control the flow of signals within the system, directing data to the right place. Flip-flops and the registers, they are used to store bits of information. They play a very vital role in timing and memory. It is critical for processing spoken words and signals. The logic behind the intelligence. Speech recognition. Speech recognition. Digital logic enables the processing of digitized audio signals, helping algorithms detect and identify spoken words. Natural language processing. Logic circuits in processors execute complex computation that allow the system to understand context, meaning, and user intent. Task, task execution. Once the intent is understood, digital control logic converts it into the specific commands, triggering actions like setting reminders or turning on lights. That are the commands that you as a user gives to the voice assistant, and at last you get the output. Integrated circuits, the heart of voice assistants. ICs, that is the integrated circuits, are the cornerstone or the heart of the modern electronic systems, containing millions to billions of microscopic transistors. These transistors form the building blocks of logic gates that perform critical computational tasks. In voice assistants, ICs incorporate essential components such as CPUs that is used for general processing tasks, memory that is both RAM for temporary data storage and ROM for permanent instructions, DSPs that is digital signal processors specialized for processing sound signals, enhancing voice recognition, and handling real-time audio tasks. All these components work together seamlessly, powered by digital logic principles to enable the sophisticated functionality of voice assistants. At last, I would like to conclude that at the core of every voice assistant lies the digital logic, the foundation that makes the intelligent responses possible. So, behind every Hey Siri or Alexa, that is, behind every command of the user, there is a world of logic gates, flip-flops, and digital circuits working in harmony. What seems like magic to us is actually the result of precise hardware level logic driving complex software. Thank you.